All right, hello all. Today I thought I would look into doing some AI code work with Unity and unit testing. So we'll see how this goes. Kind of do this live and see where it takes us. So what I've done right now is create a pretty much an empty Unity project. So I haven't added anything in here. I guess I added a scripts folder. Looks like that's pretty much it. So we'll start setting up some things, some basic things I know I want that are easy. Probably could have AI do some of this for me, but I'm gonna maintain some control here and see if I can set up some structure. So I'm gonna put a UI folder in here, and we will create a UI toolkit. We'll call this calculator UI. We will need it's UXML, so we will need a panel settings, panel settings asset. There we go. So we'll put that in here. Call that just panel settings. Okay, so that's all we need there. Inside of scripts, let's create another folder for UI, and let's do another one for we'll call this core. Um, in UI, let's create a mono behavior script for this will be like the file that has like button response to button events and things in the UI's UXML document. And inside of core, we will create a regular C# script, and we'll just call this calculator. So this will actually be like, for lack of a better term, the business logic, I think, of what a calculator is and does. Okay, I think that's pretty much it there from a files structure. We're going to create an empty object up here. We'll call this guy UI, and we will add a UI document. From here, we can have the panel settings, and we can drag our UXML into the source asset. Okay, again, that stuff's all just empty at this point, so no big deal. All right, so now I'm going to go into Claude. You could do this with Codex just as easily, I'm sure, but I picked Claude today, so I'm going to open a folder. I'm going to find my project, Unity projects, and call this Traveler VTT, something I'm sure I'll never get to finish. But so again, we'll just start telling AI like what we want to do. I'm going to leave Claude in plan mode for now. So I know I want the calculator. Yes, should implement common calculator operations, like add, multiply, etc. The calculator UI controller. Actually, do the maybe this will make more sense logically. We'll do the calculator UI.uxml should include a display at the top and standard calculator buttons for numbers and common operations below that display. So that's there. And then for the controller, this should handle the, well, actually, it should get the UXML from the game object. This script is attached to. So we'll have to do that probably when we come back. this script should handle all of the button clicks and call the calculator class or any math operations. Okay, so that's a good start. I think we'll see. Um, so we'll let it run for a bit. I did not put this in GitHub, I don't think. Maybe I did. But maybe I'll do that eventually and post the code out there for others to check out. But it's pretty simple. I picked calculator for a reason. So from a unit testing perspective, I thought this would be easy to show unit tests. Also, it's a common sort of set of operations that anybody watching this should be able to understand. It's not, we're not trying to confuse people with the operations. We're trying to make sure we are learning about how to, write this code, with AI, but also then unit test this code inside of Unity. So I wanted to start with something simple. We may make this a cool RPG character creator or something later, but we'll start with that. As you can see, it's just exploring the project structure. I'm using Claude Desktop. I should have mentioned that. And I just have it currently set to Sonnet 4.6, only because I don't think this is going to be something that requires a lot of thinking. I could easily bump this up to, Opus or something instead. But I just don't think this is going to need that. All right, so we're a minute something into this. And it looks like it's done with its analysis and thinking about designing the implementation. All right. So shortly, I think, we should see its plan. Now, I could have ran this just to automatically push the edits down as well instead of doing it in plan mode. I like the idea, especially when I'm doing a demo like this, of showing the plan before I tell it to implement. Depends on what I'm doing. Sometimes I just tell it to implement. See what we got going on here. So I just kept a little arrow over here, so you can kind of see how it's thinking a little deeper. Not much to see still yet. It's just kind of assessing the scene. Knows there's a game object called UI. It found the UXML file. Sort of parsing the different requirements I gave it, coming up with some assumptions, how it's going to tackle the layout of the UXML, how it's going to put some of the logic in place. So I like that it followed my instruction here, getting the UI document from the component. That's a part of the game object it's attached to. So that's good. So yeah, it seems like it's understanding what I wanted to do. Here it's asking some questions, which I could use as a way to go back and like refine if I didn't think it was going to do a decent job of this. We'll see what it comes back with, but I'm not super worried about it based on what these questions are. It's taking a little longer than I thought. But we will see. All right, so it came back with a plan. Looks like addressing some design questions. Stateful approach is the right choice here, which makes sense. I could have gone either way, but from a unit testing perspective, I'm glad it picked stateful. That'll be helpful. And then fine with these naming conventions. Doesn't really bother me as long as they're consistent. All right, and then show me the files. Right now, I can go ahead and look through all these, do a little bit of a code review, for lack of a better term, see what I think is worth doing. While I'm doing that, though, I'm going to go ahead and hit accept here and let it start working. This is where I could revise anything I think was problematic in the plan, but I'm just going to hit accept, let it start to go, and then we'll look through this a little bit out of order, right? But so yeah, so it's looking at the 3 files I told it to, found all that. That's great. It found the scene. There's only one scene in this game, of course, since I just started it. It creates an enum. Yeah, you can write that. It creates a new enum and starts to aggregate the pending operations, the current total. So yeah, nothing surprising in any of that. Just have to click allow over here. Yeah, so that looks pretty good. From a UXML standard here, it sort of threw out a potential layout. I'm not really picky at this point, so no problem. Maybe I'll come back and make that different, fancier, add more buttons in later, but seems reasonable enough to get started. So nothing special there. Um, okay, and then in the UI controller, again, I expect this to be pretty straightforward. It's just going to have button events wired up. So yeah, nothing crazy there. And then it's giving me steps to take to make sure that I'm setting everything up correctly on the Unity side that it would have trouble doing for sure. Um, and then I can get some steps here to manually test, hey, is this thing working correctly? So it's all done over here. I feel like we're in an okay state. So let's go back to Unity. All right, it's going to do a quick compile. And wow, that does not look right at all. That's okay. Again, we can play with this and get it into a better shape as desired. So I'm going to go up here. I'm going to click on this UI object. Notice that I do have the UI document over here, but I didn't add the controller script, so we'll do that. That was one of the steps that it needs to do. So now the script knows how to find that game object, which has the UI document. So that's pretty cool. Again, if I play this game, my guess is it'll function, but probably not look very pretty. So let's make this a little bit bigger, actually. So yeah, I mean, those buttons are not laid out at all like it said it was going to do. But if I did like 7, there's tiny, tiny, tiny 7 up here. Let's see if I can make that bigger. There we go. Oh, now we got some weird overlaps. So, okay, interesting. So 7, actually, let's make that a little bit smaller then. Let's do, oh, let's go wrong way. There we go. Come on, scale down. What is Unity thinking here? Weird. Why can I not? Huh. All right, well, maybe we'll try. All right, so we still got, now I have a 9. So we have 9, 9, and then we'll do plus 2 equals 101. I know that's probably really hard to see because it's hard to see on my side. Again, this layout is not great. So we'll ask to fix some of that. No problem. All right, but it looks like functionality-wise, it is behaving as a simple calculator. So we'll stop that. We'll come back in here and say the calculator UI.uxml looks like a vertical stack of buttons rather than laid out as described in the plan. Please take another pass at that. Okay. And this time I'm just going to tell it accept edits, and you can see the differences on that. Um, Mostly because I don't think we need a plan here. We know what the plan was supposed to be, so no big deal. So anyway, I can close this, don't care about that. Let it do its thing. So there are times you have to iterate like this, and so that's the first thing I tell people about AI is it's rarely exactly when you get into complex things, complex operations like writing code, it's rarely exactly what you want the first time. And that's a couple of different reasons, right? It's not always, good at what it's trying to get done, like that layout, obviously poorly implemented. But then also my instructions could be bad, right? Maybe I wasn't clear enough about how I wanted the layout to work, or maybe I wanted to have it create a USS file to store my styles in, but I didn't tell it that. So it just put everything in line. So those are things that, you may come back and expect to iterate on. And as we get into the code, you'll see that it obviously helps to still have the skills to do these things yourself. It's not that I would ever recommend, like, hey, this is for somebody to sit down who's never done anything with Unity or code and just go use AI and start creating games. I don't think that that's going to go very well. You might get something and you might be pretty impressed by the thing that you get, but it's probably not going to be the robust and complicated thing that you might hope. So anyway, hopefully that's done, and we will come back to Unity. Hey, that looks a lot better already. I mean, it's up in the corner. I don't love that, but we can go make some adjustments ourselves if we want. And again, that's where it pays to know a little bit about the tools you're using. Okay, so you can see as I play it, it's just stuck up in that top corner. I can change the scale. It looks a little more usable. So now if I do 71 minus 5 equals 66. So again, it's functional. That's cool. And again, I could play with the size of this thing or whatever by opening up the UXML. Come in here and make sure, I don't know what let's see, it looks like they hard coded in width and height. So maybe I'm just going to set that to auto on both. And then if I save that, close it, that's not really pretty either, but at least you can have the width of the screen. I don't know. Again, you can play with this and make it be whatever you want. Okay, that's again not totally the point of this video. All right, but I've got that. Let's open up the code now, though, and look at that a little deeper. So what it actually implemented. Again, I would highly recommend you do that. So this is the character or the calculator controller. Input buffer makes sense. Obviously, it's once a reference to our stateful calculator class. That makes sense. Creates a new instance. Maybe I would do that as a singleton or something, so I could change that. Here's a warning that it didn't do, so recommends require component. I've seen it do that for me, but this time it didn't. That's fine. We'll just go add that in. And getting the different controls, making a dictionary of controls, mapping the button name to the math version of that number. That makes sense. Adding a bunch of click events looks fine. I think Unity prefers the register callback approach rather than this. So again, I could tell it, hey, go do that for everything if I wanted to. No need for an update method to be implemented. I could probably just delete that. So yeah, different digits are pressed, so it passes in the digit, makes sense. On decimal pressed, you get start to create a floating point number. Different operations, then calling the calculator. We'll have to look at that code. But yeah, this looks reasonable, right? Again, maybe some things I do differently, but it's definitely functional. Okay, so we'll go over to the calculator now, calculator class, and look at that. Let me scroll to the top first. So there's the accumulator again, the operations in whom, the current value as it's calculating this. That makes sense. Set the operation it's currently doing. Okay. Executing that. Okay. So it's just taking whatever your accumulated value is minus the display value or whatever that operation is. In this case, multiply. Down here, there's divide. Okay. Yeah, so, it's checking for not a number, which is nice. All right, so that looks pretty good. I'd say that's all fairly reasonable. I'll save the few changes I made. I think we're in a decent place here. So I'll let it compile again. Now, when you're getting into unit testing, Unity does require you start to define assemblies. And there's a reason for that. So if I come in here and I create a folder called tests, well, that's fine. I can even put inside of there, create testing, a test assemblies folder, right? So all this is kind of set out for you, which is nice. And, oh, didn't mean to do that. Sorry, I clicked on the wrong thing. Delete that, start over. We can have it even, we'll make it a little even easier than that. We'll go to assets and create a new test assembly there. So it'll create that test folder for us and then drop the tests assembly definition in here. So an assembly definition starts to break these things up into smaller binary libraries. So that's important here, right? Because as by default, this whole project would compile into one binary library. And you probably don't want to have your tests inside of the same binary as the rest of your code. At the same time, you don't want your game to ship with your tests, and you want to have some separation there. So by default, that's what it does. We'll come back to this folder here in a second. But to really make this a little more professional, we should probably come in here and make sure that these have assembly definitions as well. Um, so I come in here, I can say create, and I go to scripting. Whoop, that scripting assembly definition, and we'll call this guy, let's do traveler VTT dot UI. That's not super creative, but that's okay. And then inside of here, we'll do another one for the core. So we'll do the traveler VTT dot core. Okay, so now when this builds again, these are going to be their own assemblies. And what that means is now I'm going to get compile errors because now, since these are different assemblies, there's no reference between these two. Um, in this case, the UI here doesn't know about the calculator that it's trying to call from the controller. So we have to come in here and say we want to reference, and then we can find traveler VTT core. And now we have a reference to that. You do have to hit apply down here. Something I always seem to forget to do. So click the little apply button, and then it will compile again. And shortly, we've gotten rid of that compile error. So now the UI can call the core, and if I run the game, everything should work as it was before. So 5 times 3 equals 15. So we're still good. But we haven't finished that because tests still can't call core or UI. There's no reference there. The only references are to the Unity engine test assemblies and in Unit, which is the default unit testing thing for Unity. So, which is fine. So I need to fix that. And obviously I need to start creating some tests. And we have two options down here. I did a view on the test runner here. So you actually have edit mode, play mode options down here. We can do this different ways as well. So for instance, I could delete this guy, this assembly, and let that go for a second. Just wanted to show you guys how that could work. And then I can come back down here and I could say, well, actually, let's do this. Let's do create folder, and let's do editor, or edit mode. Maybe let's keep it consistent there. So let's do edit mode. And let's do folder play mode. And again, I could have AI do some of this for me. I guess I call it maximizing my control of the structure so I know it's going to put things in the right place that I really want them to be in. So now again, for play mode, I could say, hey, create a new test assembly folder here. And I could give that a name like play mode tests, let's say. And in edit mode there, I could give this guy a name called edit mode tests. That's probably too many folders, to be honest. I could change that if I wanted to, but that depends on what you want to do, I suppose. Like I can move this guy into tests and move this guy into tests. Then I can get rid of those parent ones. That's probably smarter. A little cleaner, maybe. Okay. But again, we've got references here, but nothing else set up. All right, so let's head back to Claude and take this to the next step. So I have set up edit mode tests for unit testing calculator CS. I have set up play mode tests for integration testing of calculator XML and calculator UI controller.cs. This calculator UI XML, I think. Okay. So I'm just giving it some hints. I mean, it probably would find most of that for me. Please generate a comprehensive but professional. So it's really and professional. And professional set of unit tests in edit mode tests and create integration tests play mode tests. Okay, so now I'm going to come back in here. I'm going to go to plan mode again, partially because I just want to show you guys how it's doing this. We'll see how that does. I use a very different prompt where I did this last time. So I'm trying something here. See if it can figure out a little bit more what I mean by unit testing, what I mean by integration testing. See if it understands that I'm pointing it at calculator CS versus the UI components of UXML and the controller. What I'm hoping it'll do is write the unit tests for the various math operations in calculator CS. And at the same time, I'm hoping it will write some integration tests verifying that, hey, when I'm clicking, certain buttons, they're the correct output, whether I'm pushing the 7, let's say, that shows up in the display panel. And when I push 7 plus 7, all of that shows up correctly and shows up in the display panel with the result. So that's what I'm hoping it'll do. But based on what I gave it here, we will see what it kind of can come up with. We'll see how long this takes as well, I guess. So yeah, so now it's just reading through the solution. Nothing crazy there. One other thing I should have mentioned, I didn't even look at this, I don't think, but obviously as I created those things into different assemblies, they need to be marked with the appropriate visibility level. So if calculator was initially defined as maybe internal, well then as I broke apart those assemblies, calculator UI controller wouldn't be able to see it either, right? Obviously that wasn't the case because the calculator worked when I ran the game. We didn't have any compile errors from that. But those are things that would potentially break as you set up assembly definitions within your Unity project. So something to keep in mind as you're doing that. I like it by default. I can't remember the file it compiles things down to, but it's some generic name that your project scripts get compiled down into, like default assembly or something like that. Anyway, now when you ship your game, your files would actually be called exactly what you wanted them to. So in my case, traveler_vtt.core and traveler_vtt.ui, which is, well, first of all, probably more professional looking. You have your brand, your game name in there. But from an organization perspective, right, like this might be how you update certain assemblies and not others. Um, maybe you have certain assemblies you really work on supporting for like modders, right? And so you can now break things apart and say, hey, this is the only part you need to care about, right? Is these over here. So a lot of cool things you can do as you get down to that level, not just for unit testing. So we're 3 minutes here. Sometimes this does take a while, and so you do have to balance that as a developer as well. So some things are just easy, right? Like you might be like, hey, Jeff, creating that calculator class, that would have taken me like a minute. Okay, great. We'll go do that because that's faster than the AI was going to do it as it tried to like consume the context of the project, etc. But I, especially as I get good at figuring out how to do prompt engineering with complex code and with Unity or Unreal Engine, um, as I get better at that, I'm finding myself, pushing more and more to the AI And I'm really just making sure I'm like the lead designer and, slash engineer slash tester, game designer. Like my role is shifting to that, which I love. Like it's letting me do the stuff that I really enjoy doing, and not having to, make sure I put all the same exception handling in, or like I can let AI do the stuff that I feel like is more tedious. Important maybe, but tedious. All right, so now it's looking like it's doing that. Still kind of understanding, I guess, the layout of the new project, which is fine. I'm at 4.5 minutes here. And we'll evaluate, I guess, as you're watching this, hey, is that worth the time taken or not? I think you're gonna find it is, but it's gonna generate quite a bit and um, be worth the productivity gain. Obviously, it's showing you the line count changes that it's recommending for some of these things. Those aren't final until they're final. So these might shift as the AI continues to run here. But it might give you some guidance as to where it's headed. So, okay. All right. So already it's off to a pretty cool start, I think. So you can see as it scrolls by here. There we go. Assembly references, it went ahead and updated that. So it said, all right, well, I see you have edit mode tests, but edit mode tests aren't able to get to calculator by default. You had references only to in-unit and the Unity test assemblies. So we added reference to core. Play mode test needed a reference to both core and UI. So, okay, we made sure that it had that. From an edit mode unit tests, all 4 operations, including several edge cases, right? Looking for divide by 0 and things like that are in here, as we would expect. So that looks interesting. Play mode integration tests, so UI initialization in presence of all 19 buttons. Looking through, making sure that it's calculating and clicking on all the various buttons. The gate applied once and twice to see if it would, toggle plus or minus on a number. So that's all good stuff, I think. So I ended up with 25 tests, which seems interesting. Um, so we can come out here. That's our plan there, right? And let's see if it made our changes. Tuned. Okay. Looks like we have a lot more than 25 tests. I guess it was thinking, so it said 25 for play mode. We ended up with 28. Edit mode, it didn't give us a number of edit mode tests, but it looks like it found 52, which is a lot. Um, so let's go look at some of that code and see what it did. So first of all is our calculator tests. It's a little bit big, maybe that's a little bit better. All right, so we have a section here for setup. We're creating a new instance of calculator. And then we have various add tests. So 2 positive numbers, 8 and 5, it looks like. Add 2 positive numbers, return sum. So 5 and 5 and 3. I'm not paying attention. Okay, so it's adding 5 and 3 together, and then the expected value is 8. So it's a pretty simple one for add. Here's add positive and negative numbers. So 10 and -7 should end up with 3. Makes sense. So all these are adds. Subtracts are probably pretty similar. Subtracting to get to 0. Negative from positive. All right, so you can kind of see what it did here. Let me scroll down a bit more, see if we get some more. Okay, what if there was no accumulator? So this is a little more like something went wrong, I think, right? You tried to, in this case, put in a 42 and execute, or sorry, put in a 42 and then execute. Well, it should show 42 as a result. Like there should be nothing else in there when you look at the accumulator plus the display value. So that's what's doing there. I don't know if that's the most effective test, but sure. Negative numbers. So again, you've got a lot of tests here, and then you can evaluate like some of these you like, some of these you don't like, you want to add to it, whatever it is. But dude, that's a pretty good chunk of tests. So cool. Okay, so then I can come back here for a second, and that was edit mode tests. So these are just tests that I can run without playing the game at all. Maybe the game doesn't even run for some reason right now, but I could still run these tests. Um, that's what edit mode tests are all about. Play mode tests actually require the game to run. So that's the difference between these two modes. So this is a very different set of tests. These are more like I said, integration tests. So you're actually testing, hey, what happens when I push a button and what response do I see somewhere else on the UI, or does the player experience, do they see an animation play? Do they see an explosion in the background, or does their ammo tick down correctly on the gun? Whatever it is, those are more like play mode tests. Now it looks like either I did that wrong, which is super possible, but looks like I did not create those as play mode tests. So we'll see if we can fix that, because that's not how we want those to run. Um, but anyway, we'll look at that. Maybe I probably did that wrong. I probably created them both in edit mode. So you know what? Maybe we'll just delete that. Let's do that. This might be kind of fun to do anyway. We'll go back to tests. Now we're in play mode, and let's go to play mode tests. Okay, we'll get a new assembly definition, and we'll go ahead and tell Claude to work on those. So I had to recreate play mode tests to be actually in play mode. Please recreate or regenerate, I suppose, regenerate those integration tests. Those integration tests covering calculator UI.uxml and calculator UI controller. Okay, let's see if that understands what I'm trying to do. Hopefully it will. But we'll go back to Unity while it's sort of thinking through that. Okay, so this is where I've got all my edit mode tests done. Great. So let's go back to edit mode and just it's updated already here. And then let's run the tests. I don't know why that's off the screen a bit, but we can come down here, we can run the tests. Now, unit tests should run super, super fast, right? So good news is we just ran all of our 52 unit tests without running the game, just in edit mode. And bam, we've got green check marks all the way down. Now, again, evaluate the quality of these tests, add your own tests, remove tests you don't care about, but or you think are bad tests. But that's pretty awesome, right? Like you are now ensuring that you have unit test coverage of the calculator. And as you added more buttons and operations to the calculator or changed the way you had it working in some other fashion, no problem, because you could easily run those unit tests again and make sure everything was still green, or you could generate more unit tests either yourself or using AI again. So that's pretty cool, I think. And yes, it took whatever it was, 4 minutes or something, to do that. But that's pretty awesome, I think. Like you got a lot of productivity boost out of that. All right, so let's go back, see how this guy's doing. All right, the assembly def is now a true play mode assembly, no editor restrictions, so Unity editor namespace isn't available at compile time. Cool. All right, so now that test file is rewritten. Still saying 25 tests. Let's see if that's true. Okay, so let's go back here now. It's recompiling. Looks like I'm missing a using directive. That's interesting. So it did not add a reference to UI and core this time, which it did last time, if you remember. So that's interesting. And I think that is probably a problem here, but we'll see. Okay, and so let's go ahead and do that. Again, we could tell it to do it, but this is one of those operations that's going to be faster for me to just do myself, right? So let's do this and grab. So we know we want UI, and we might as well throw core in there. I think it'll need that too. Okay, because it needs to create an instance of the calculator object probably. Okay, so now we've got that. We will save down here. Hopefully that will get rid of our compiler. Cool. And now if we go over to play mode, we got 28 tests. So again, it was a little bit off. 25 it said, and actually gave us 28. But let's go look at those tests and see how it did. Do it this way a little faster. Okay, so here's the test for the UI controller. So let's see here in setup and teardown. It's loading up our UXML file with the panel settings, getting creating a new game object called calculator test. So it's not using what's in the scene, right? It's creating its own, which I don't know. It's up to you what you want to do there. And then we have the component added to it. So it's recreating all this from scratch, which again, I don't know. I probably wouldn't want to do that. I didn't tell it to do it one way or the other. So again, that would probably be on me. This is probably fine to do the testing of what I think is going to be in here based on the plan. But I'd probably tell it, hey, go get the scene, right? Like you're running in the editor or in the Unity engine anyway. Don't create a new game object with a new component. Just use what I already have. And that way you're also sort of testing, did I set up the scene correctly? But kind of depends on what I guess what you're trying to do at the end of the day. Um, if you're dynamically creating game objects, then this is no different than that, and it's fine. Okay, but anyway, we got some helpers here. So a click helper finds a particular button or not, and then sends an event. Oh, that's just getting the displays text. So I guess that was up here somewhere. Yeah, display label. Okay, and then here we have the various actual tests. So initially, do we see a 0? Are all the buttons present? That's fine. If I push a particular number, do I see that number in the display? Looks reasonable. Complex number. Okay. So again, I'm getting a bunch of tests, right? So now when I come down here, I should be able to go into play mode and hit run. And if things are working correctly, let's see, GUI layout state in view. Some kind of null reference there. Well, you know what? Let's do this. Since it's unlikely that I made that particular mistake, let's grab a screenshot of that and let's say, hey, Claude, can you tell me about these errors associated with the new play mode tests? And can you change the test setup to use the current scene rather than creating your own game object and adding components to it? Let's see how that goes. And that may take a second again. There's a couple of complex things in there, including the error, which I have not seen before. So I don't know. But we'll let that go. See how that kind of runs. Watch my tokens ticking up here. Let's see, where am I at here? I guess I did some work this morning though too, so I don't know if how much I've actually spent today, but looks like I'm nearing half of my 5-hour limit of tokens, and I think I just got the $20 a month plan in here. for Claude, I think. Okay, so about the errors, test runner uses reflection to build its test list. Okay, so it's like, yeah, crashing the GUI because of what it was trying to do there. All right, so now we've completely eliminated that by doing the second part of what I asked to do, loading the sample scene. Maybe that's why I've not seen that before, because I've always tried to just load the existing scenes. Must be in file build settings. That's something for me to check. Should be there by default, but this is the brand new project. But we will check. All right, so it's telling me some things to confirm. It made a bunch of changes. Let's go see how it did. So let's go confirm the build settings first, which again, it should be there. So file, build profiles, scene list, sample scene. So yeah, it's there. So that's not a problem. Oh, it looks like it used some obsoleted code this time. So that's interesting. We can just tell it to go fix that real quick while we go look at the code itself. So please state code for the message. All right. So we'll let it do that. Let's go back out and look at some of these tests. So again, we're still at 28 tests, it looks like. So that's good. Looks like it fixed that already. And inside of here, let's go back to the setup. Tear down. Okay. Yeah, so now it's just loading the scene, which is what I expected to see initially. Um, Doing some checks for if the UI document was there. Okay. All right. So let's see how that runs. It looks a lot better. Oh, still getting the same, I think, same error. Yeah, that looks like the exact same error. So let's try that again. Still in this error when running play mode tests. Let's see what it thinks of that. So yeah, giving it like screenshots of the errors you're running into is really cool, right? Like you can tell it go work on this and figure out troubleshoot that thing, while you go work on adding another feature or something like that. Or do what I'm doing and look at other code for different reasons or set up the scene or whatever. So working asynchronously is also another productivity boost, right? I can have it go figure out some things while I do other things. Yeah, so it took out the if Unity editor, which it thought was causing the problem. Um, so that'll be interesting to see where it goes from there. Uh, I didn't even look. Yeah, no, yeah, it got rid of that. So I don't know. These are all just tests. I don't think any of these are going to be the problem. I do think it's pretty clean. I mean, I probably would have added, comments in the day, like more than just, well-named unit tests. I probably would have put comments at the top of these describing what I was trying to do a little bit better, but I probably also wouldn't have tested, every single combination I could ever think of. So this is, pretty good. I like the handlers, what it did here. It makes it more readable and clean as well. So I can tell negate mid-entry negates current input, like you're pushing the number 5, adding 3, hitting negate, hitting equals, you expect to see a 2. Like that is cool, right? So what happens when you hit plus and then minus 3? Um, does it do it correctly? I like the way that it does that. You can pretty much read that test, so it's always nice. Like still thinking about the error. Give that a second. Let's see, not quite crossing the. Oh yeah, just over the 51% for 5 hour limit. It's not too bad. And again, I'm doing some stuff here. In a normal day, when I'm not recording a video like this, I would probably be working on other tasks while this is running, or I'd be investigating on my own potentially. Like, hey, you go investigate. I'm gonna go over here and look at the, I don't know, Unity documentation or something. So it's kind of nice, or I can go have lunch or whatever. All right, 3.5 minutes in here. Um, some people will debate unit tests and integration tests too, and the value of those. I think when it comes to gaming, they both have their place. I don't. I definitely prefer to make sure I have unit tests um, over integration tests, just because what I'm gonna call the fragility of integration tests. Like if I change the UI radically, or there's a lot more dynamic stuff happening in the UI, which is not uncommon with games, maybe that's not worth writing lots of integration tests for. There's a lot of randomness in many games, so that can be hard. Um, so those are all potential challenges with integration tests, but I do think they're valuable. And when you do have something that can be fairly easily integration tested, it's kind of cool to be able to do that. So, all right, so it happens at test discovery time. That's not what I saw, I don't think, but maybe. Non-execution time, test runner user reflection. In unit has legacy recognition of setup as a special name. So affixes rename in Unity setup method to something that doesn't collide with in-unit's legacy name detection. Interesting. So setup rename to load scene. Okay. That seems strange, but let's give it a shot. So it compiles. See, it looks like it found all the tests. And when I hit run, oh, well, we got past that error. So it runs through, pushes a bunch of the buttons. Looks like some are working, some are not, which is fine. So yeah, so we got 4 passing and 24 failing. And I'm kind of glad we got some failures because I wanted to be able to show you what happens when that occurs. So right, expected string length is 2, but instead it was 1. Um, it got it expected to see a 10, but instead got a 0 for add 2 numbers shows correct result. So again, this is where you can kind of get into the code and how it worked. We'll go look at this one real quick, but obviously I'm not going to go through all 24 of these and make you guys sit through that. Um, it'd be interesting to find, you could potentially send this back to AI, this whole output, and say, hey, like we've got a bunch of failure tests. Let it hash that out. Let's go look at this particular one, add 2 numbers and show correct results. Oops, didn't mean to do that. Just gonna run it again. I meant to go in here and find add 2 numbers, show correct result. So 7 add 3 equals 10. Yeah, that looks like that should be fine. Was expecting 10 and got 0. That's really crazy. Why would it have done that? Well, let's try and do it ourselves. So 7 add 3 equals. Let's go play. 7 plus 3 equals 10. So, yeah, that is Weird. Why would it? What was 0? Huh. Let's see if we can copy that. 20 of the 4 play mode tests failed. Um, Here is the output from one of the tests. What went wrong? How do we fix this? I did put double quotes around that error message. I tend to find that helps if your message has lots of double quotes. Probably not doing much for you, but this one has minimal double quotes, so hopefully I'm helping sort of tell the AI this whole thing is the message. Um, so I do find that that is a good tip. A couple other things like when it comes to these prompt engineering tests, like it doesn't usually care about capitalization. Like the folder was actually called capital P, capital M, capital T play mode tests. Um, but it usually figures that out without a problem. But that does, it might be something you have to be careful of depending on what you're doing. Also, there are times if it's a commonly used name or phrase, I'll put that in, single or double quotes as well, right? So that I make sure, hey, if the actual output I'm looking for is here's the output, then I would put that in double quotes to make sure that it knew, hey, that's what I'm talking about. So there's little things like that that can help you. You saw me put, these are just one line each. Up here, I told to do two things. Tell me about these errors, and then change the whole setup. Um, in this case, worked okay, I guess. But you might want to make sure that you're doing these things, you keep them small and atomic if they're not getting the results you want. Sometimes, many times, you can have it do 3, 4, 5 things. I had to set up all those files way back here, set up all 3 of these files pretty well. I mean, the UXML needed a little bit of revision, but for the most part, things were put in there and there's a lot of different activity. So it can do a lot, but if you are having problems with responses, that might be another thing to look at. Okay, problems in the click helper, click event.get pooled plus send event doesn't reliably trigger the button's clicked action. Now see, this is interesting because Unity's button fires clicks through internal clickable manipulator. Okay, not the click event directly. Fixes button clickable invoke. Simulating a button click. Interesting. All right. Well, so maybe the way it was automating the actual click event was causing issues. So let's look back at that. Still in play. Let's come out of play mode here. Um, let's come up here. So it didn't like that either. So grab a screenshot of that, pass that in. Now I'm getting this error. See what it thinks of that. So again, some of the stuff you guys, if you have a lot of unit experience, you might know offhand, like, hey, this is how you're supposed to do that. I actually don't know that. So what is the best way to handle clicking buttons in the UI? I don't know that offhand, at least. I've probably done it before. But another great example of how you could use AI to help you here. And then what I can do once I get this back, if it's not clear, I can even tell it, hey, please explain this to me, or please point me to the Unity official API for programmatic button clicks. And then I can go read about it myself. So you're not just throwing it over the wall and not understanding it. I'm going kind of fast through this video, but it is important that you use this as a tool to learn, not just do. So that's a clickable button. Go back here to Claude. Just reading through this again to see. The events get dispatched, but the regulator state machine doesn't register them as valid clicks, so the handler doesn't run. So this is saying the fixed call through reflection. That's interesting. Don't remember having to do that. Okay, let's come back here, let that compile, and we'll look at the code again. Okay, so we have a new file. So let's run these tests. Let's do rerun failed. Okay, so we have a lot more passes already. Looks like we got all 28. Okay, interesting. So now let's look at the code. Again, I'm gonna throw this over the wall. Like, what is it doing? So nothing in the setup. Here we go. This is the clickable invoke. Let's go look at actual tests. Okay, so it's still calling click. That's good because I like that pattern. And then inside of click, we're getting the button name, or the button by that name, and then doing a click event get pulled, and then this is the invoke it was talking about. So here, type of clickable, get the invoke method. Okay, I guess that's reasonable. Yeah, I'm gonna investigate on my own to see if like that is the actual best way, recommended way to do that. But I guess it's reasonable. Let's just use reflection to figure out where that invoke method is, since it's protected. Otherwise, which is not ideal, testing protected things, but and then it's just calling that click so that the tests themselves didn't change, but how it was calling click. Okay. So again, at the end of the day, you can decide, what tests are valid for you and your game, more importantly, maybe, and decide what kinds of tests, integration and unit you want to spend more time on. But in any case, I hope you consider using AI to help you do it and learn a lot about it. So thank you for your time.